welcome you all to session 8 of the chapter Units and Measurements. We were discussing about applications of dimensional analysis. The three main applications of dimensional analysis are: first, to check the correctness of an equation; second, to derive the relation among physical quantities; third, to convert one system of unit to another. We have already completed first one, to check the correctness of an equation. In this session, we will be going on with the second application of dimensional analysis, that is derivation of relation among physical quantities. So, physical quantities will be given to you and you need to find the relation among the physical quantities. One sample problem is on the board now here, right? The problem is like this: a centripetal force on a particle depends upon mass. Okay, force depends upon mass of the particle, velocity of the particle and radius of circle. Right, force depends upon three quantities. One is mass, another one is velocity and another one is radius. Right, obtain the expression for F by the method of dimensions. You need to find what is the formula for centripetal force by using dimensional analysis. First of all, what is given? Let us check it out. Do remember, in the examination, question will be asked like this. Right, they will be giving you the physical quantities and you need to find the relation among them now here, right? Okay, the first one, centripetal force on a particle depends upon. Let me take centripetal force F. It depends upon, let me take proportional. It depends upon first quantity. What is that now here? Mass. Right, let me take, it depends upon mass. Right, we don't know is it depend directly or inversely or any power of the m now here. So let me take m raised to x. Right, okay. Second, it depends upon mass of the particle, and second is velocity of the particle. Let me take velocity of the particle v. Let me write v raised to y. Right, again we don't know is it directly or inversely or any power of the v. Right, okay, let me take it as v raised to y now here. Right, and radius of the circle. Okay, let me take now here, it depends upon the radius of the circle. Let me take it as z. This is how we need to begin with the derivation using the method of dimensions now here, right? So we are deriving the relation among physical quantities. We are deriving the relation among these physical quantities, right? In the question itself they have given that centripetal force depends upon three quantities. One is mass, another one is velocity and another one is radius of circle, right? We don't know. We don't know how it is dependent, right? We are deriving that by using dimensional analysis. So I will be taking it as x, y, z. Right. Next, I will be finding the values of x, y, z by using dimensional analysis, and thus we will be arriving at the formula for centripetal force now here. Right. Okay. Next, what to do? First, you need to write this in a mathematical form now here. The same question, the whole question I have written in the mathematical form now here. Now let us check it out how it is dependent now here. Right. Okay. Remember that whenever we remove the proportionality sign, we always write a constant. Right. Constant m raised to x, v raised to y, r raised to z. Do remember the constant k is dimensionless. Do remember the constant k, the number what we get, it is dimensionless, right? So it is a constant and that constant is dimensionless now here, right? Now shall I use dimensional formula now here, right? Okay, how to write? No, we know what is the meaning of dimensional equation. Right, dimensional equation is an equation obtained by equating a physical quantity with its dimensional formula. Let me do the same thing now here. Let me equate the dimensional formula of all these now here, right? Okay, first of all, write the dimension for force. Force, what is the formula for force? Mass into acceleration. How to write? I already told you. Force means what? Mass. Acceleration, L t raised to minus 2. Don't remember the dimensions of all physical quantities. I told you to remember only two. One is velocity and another one is acceleration. Velocity, L t raised to minus 1. Acceleration, L t raised to minus 2. Right. So if you remember the formula directly, you can write the dimensions like this. Force formula is mass into acceleration. This is mass. Acceleration is L t raised to minus 2. That is equal to, right? This do not have any dimensions. Leave it. Next, what is the dimension of mass? Dimension of mass is what? M, right? Okay, m raised to, shall I take it as x into dimensions of velocity. What is the dimension of velocity? L t raised to minus 1. Do remember this. Let me take it as y. Right. What is the dimension of radius, man? Radius. Radius is nothing but what? Distance. That is why let me take it as L. That raised to what we see here? Z. Radius is nothing but distance. It is nothing but length. Let me take it as L. This is how I have written here, right? Okay, let me simplify. What do I get? Let us check it out now here, right? This is m raised to x, right? Okay, what do you get here? L raised to y, t raised to minus y. I have multiplied, right? Okay, what do you get here? Let us check it out. L raised to, what do you get now here? Z, right? Okay, now let me write in the form of mlt. M, is there any m here? No, let me take it as m raised to x. Let me go with L. Here there is y and here there is z. Y plus z, you know, laws of indices, right? So you know the laws of indices, a raised to x into a raised to y is a raised to x plus y. This is law of indices that you are studying, right? So L raised to y, L raised to z, L raised to y plus z. Okay, let me go with the t. So what is t now here? T, that is minus y, right? Okay, what you have this side? M L t raised to minus 2. Now shall I equate these two, right? Okay, now next is we will be equating the physical quantities. We already have that, and by equating, let us check it out. What do we get now here, right? How to continue with this? Now we have m L t raised to minus 2, and we have equating those two now here, right? So comparing these two, what do we get? Let us check it out. What is there? Power of m is 1, power of L is 1, t raised to minus 1. Let me compare now here, right? Comparing, right? So if we are comparing, what do we get? What is there in place? Here m raised to x, here m raised to 1. So x is equal to, shall I take 1? Yes. X equal to what now here? 1. That is what you have written. Come on, tell me, what is y plus z equal to? 1. Yeah, so we are comparing now here, right? So what do you get now here? Y plus z is equal to, what do you get now here? 1. What is minus y equal to? Minus 2. Shall I write like this? Minus y equal to, what do you get now here? Minus 2. So these are the equations we got by comparing the powers of m, L and t now here, right? Okay, by comparing we get like this now here, right? Now you got x, you got y, and you got z now here, right? So come on, tell me now here. First of all, you need to find what is the value of x, y. Already you got the value of x. So what is the value of x? 1 now here, right? Okay, now let us check it out. Which value you get? If it is minus y is equal to minus 2, that implies what is the value of y now here? That is 2. Shall I take this? Minus y equal to minus 2 means y equal to 2. So I got value of x, I got value of y. Then I will be getting value of z now here. How do I get? Now we have this equation. What is that equation we have? Y plus z equal to 1. But we have value of y now here. What is that now here? 2 plus z is equal to 1. What is z equal to? 1 minus 2. What do you get now here? Minus 1, right? We got value of x, y as well as z on comparing now here, right? On comparing the powers of m, L, t, we got x, y and z, right? Then we will be substituting the values of x, y, z in this equation now here, right? Substituting values of x, y, z. Okay, how to continue with this, right? So do remember this. Let me write. Substituting values of x, y, z. Okay, what is our substitute value of x, y, z? What do you get now? F is equal to, in this equation, k m raised to, what is x? X is what now here? 1. Shall I take like this? Okay. V raised to, what do you get now here? Y. Y is how much now here? 2. Right? R raised to z. What is z now here? Minus 1. Shall I take it? Right? Substituting values of x, y, z now here. Okay. What do you get? This can be written as like this. F is equal to k m raised to 1 is m v square. Shall I write it? Divided by r. R raised to minus 1 is what? That is 1 divided by r. So this is what is the formula for centripetal force, right? So this is F is equal to k m v square divided by what we say now here, r. So here, what is m? M is the mass of the particle now here, right? So what is v? V is the velocity of the particle now here, right? And r is the radius of the circle now here, right? So we got the formula F is equal to mv square divided by r now here, right? So when we get, do remember where, what shall I write now here? K is constant. But what is the value of k? That cannot be calculated by using dimensional analysis. That is one of the drawback of dimensional analysis. Do remember, the drawback of dimensional analysis is Constant cannot be calculated, right? Okay, but you know what is the formula for centripetal force? You have studied in high school level. The formula for centripetal force is F is equal to mv square divided by r. Did I get that? Yes, I got the formula, right? So this is how I will be deriving the formula itself by using the dimension analysis. But one drawback is I cannot find what is the value of constant. So here the value of constant is k equal to 1, but we don't get by dimensional analysis, right? So we can derive the relation among physical quantities by using dimensional analysis, and this is how we have derived the relationship between centripetal force, mass, velocity and radius of the circle, and this is how we use dimensional analysis in deriving the relation among physical quantities. Now let us solve the second problem. The problem is like this. The period of simple pendulum is found to depend upon, okay, there is one physical quantity, that is period, and that period of simple pendulum found to depend upon mass, one quantity, length of the pendulum, second quantity, acceleration due to gravity, third quantity. Means period depends upon three physical quantities. Obtain the expression for t, right? We need to derive the formula for t by using the method of dimensions. Okay, now let me begin to find the relation between these physical quantities. So first of all, what is given? Write a mathematical form for it. Okay, the period of the simple pendulum, shall I take like this? The period is simple pendulum, period is denoted by capital T, right? The period of simple pendulum is found to depend on mass of the bob, right? So this is the pendulum, so do understand? Pendulum means there will be a thread and there will be a bob, and this is called as the bob, and this length is called as length of simple pendulum. Right? Okay. Now, the question asked here is, it is found to depend upon mass of the bob. Shall I say like this? It is proportional to mass of the bob. Let me take it as m. We don't know how it is depending, so let me take it as x. Right? And it depends upon length of the pendulum. It depends upon length. Shall I take length? Length and raised to y. And also it depends upon acceleration due to gravity, right? So what is acceleration due to gravity? Small letter g, and we don't know how it is depending on here. So let me take it as g raised to what we say here? Z. Okay. Now we have this. We have already discussed how to find the values of x, y, z. In the similar manner, let me find here also, right? We know that when you remove this proportionality sign, you get a constant. Let me take that constant k, right? So m raised to x, l raised to y, g raised to z, right? Then I will be equating the dimensional formula for all these in here, right? We get the dimensional formula, we get the dimensional equation here, right? In place of before that, what is k? K is constant and it is dimensionless. Do remember? K is a constant and it is dimensionless. Now let me equate the dimensional formula for all these. Okay, what is this? This is period. Period means what? Time. Time for one oscillation is called as period of simple pendulum. So it is nothing but time. So shall I write the equation like this? M raised to 0, L raised to 0, T raised to 1. Because there is only time, right? It depends upon the time. M raised to 0, L raised to 0, T raised to 1, right? So equal to write k. K is dimensionless. There is a constant which does not have any dimensions here, right? Okay, next, what is this? M. M is what? Mass. Shall I take capital letter M? Right? That raised to what do you get here? X. And what is length? Length. Shall I write length as L here? Yes, right? That raised to power y here. What is G? G is acceleration due to gravity. Just think it out. It is acceleration due to gravity. Is something but what? Acceleration itself, right? So what is the dimension for acceleration? We know the dimension for acceleration is L t raised to minus 2 and it is power raised to what we say here? Z. Right? Now let me simplify. That is equal to m raised to x, L raised to y. Shall I take like this? Now L raised to z, t raised to minus 2z, right? T raised to minus z. I have multiplied now here, right? L raised to z, t raised to minus 2z. Now let me write in the form of m L t. Okay, that is equal to m. How many m we have? Only one. That is m raised to x. How many L you have? Just check it out. Here there is L, here there is L. Here y, here z. So shall I write y plus z, right? T now here. How many T you have? Only one. That is what? Minus 2z, right? Let me write what is there here, m raised to 0, l raised to 0, t raised to 1. Next step, what to do? So we will be equating here, right? On comparing, let me go with comparison here, right? Next, what we will be doing, we will be comparing the powers of m, l and t here, right? So we will be comparing the powers. So let me write here on comparing, what is x equal to, just comparing, here m raised to 0, here m raised to x, what is x equal to 0, right? What is y plus z equal to 0? Okay, let me write what we get, let me write now here, y plus z equal to 0. Then what is minus 2z equal to 1? Shall I write like this? Minus 2z is equal to 1. Okay, from these equations, let me find what is the value of x, right? What is the value of y and what is the value of z now here, right? Okay, from this equation, we get directly some values, that is x equal to, what do you get now here? 0, right? Then from here, that implies, what do you get? Z is equal to minus 1 divided by 2, right? So we get z equal to minus 1 divided by 2. So what we want now here, y, we get y by using the second equation, right? Okay, now let me write second equation, y plus z is equal to 0. We know what is the value of z down here, minus 1 by 2, y minus 1 by 2, that equal to 0. What is y equal to? If you go that side, you will get 1 by 2, right? Now we got values of x, y, z, right? So now I will be substituting these values in the equation. Let me write like this, okay? Substituting, let me write, substituting values of x, y and z, right? So let me substitute. Where do you substitute? In this equation. We want the expression for t, right? That is equal to k m raised to x. What is the value of x? 0, right? So l raised to y. What is y now here? Y is 1 by 2. So we will be getting it as 1 by 2. And z value, what do we get z equal to now here? That is g. Z value is minus 1 divided by what we say now here? 2. T is equal to, what do we get? T is equal to k m raised to 0. Leave it, right? Means period does not depend upon mass of the bob. Do remember, right? So the period of the pendulum does not depend upon mass of the bob itself. Even though we include that, then we get the value 0, right? What do you get? Then L raised to half, G raised to minus half. Shall I write like this? This can be written as L raised to half divided by G raised to half. Shall I take like this, right? G raised to minus half, this will be G raised to half. Or shall I conclude like this? That is K, that is square root. We know it is the square root. What do you get? Square root of L divided by G, and this is the equation for the period, time period of simple pendulum. So what is the time period of simple pendulum? T is equal to K square root of L divided by G, where what is K? Where K is constant. Then what is the value of K? It cannot be calculated. That is one of the drawback of dimensional analysis. But we get the relation among physical quantities, but we don't get the value of the constant, right? So from physics we came to know that, right? So do understand, we have the formula for period of simple pendulum. From other ways we can derive the relation, and the formula came to be like this: T is equal to 2 pi square root of L divided by G. This is the actual formula for a time period of simple pendulum, right? So it can be derived by other ways. So we got the formula T is equal to 2 pi square root of L divided by G. You compare with the equation what I got. Is it similar? Yes, right? T square root of L by G. But what is the value of K? K value is 2 pi. But it cannot be calculated by dimensional analysis, and it is one of the drawback. It is one of the limitation of dimensional analysis. So this is how we calculate the expression for the physical quantity which is asked in the question here, right? So till here we need to write, and we need to write K is constant, and this is how we need to solve the problem. Now let us check it out. What are the limitations of dimensional analysis, right? So what are the limitations? Let me check it out now here, right? So what are the limitations of dimensional analysis? We came to know what are the applications. Now we'll be going with what are the drawbacks or limitations of dimensional analysis. So let me take like this: limitations of dimensional analysis. Dimensional analysis. So what are the limitations? Let us check it out. Limitations of dimensional analysis. First limitation is the constant of proportionality. The constant of proportionality cannot be determined. Cannot be determined. So this is one of the drawback. We have seen that K value we cannot calculate by using dimensional analysis. So that is one of the drawback. What are the limitations of dimensional analysis? First limitation, the constant of proportionality cannot be determined. The second is it cannot be used. It cannot be used to derive a relation involving trigonometric and exponential functions. Exponential functions. Right? If the formula has trigonometric function, we cannot derive by using dimensional analysis. If it has exponential function, then also we cannot derive now here, right? So if the relation has the exponential or trigonometric function, we cannot use dimensional analysis. We know what is the formula for maximum height, that is equal to u square sine square theta upon 2g. This relation has sine theta, but this equation cannot be derived by using dimensional analysis because it has the trigonometric function, right? Now we know we have the formula for radioactivity, that is n is equal to n naught e raised to minus lambda t. What is e raised to minus lambda t? That is exponential. So this kind of equations also we cannot derive by using dimensional analysis, and that is the second drawback. If the relation has trigonometric and exponential functions, we cannot use dimensional analysis, and that is the drawback. Now let me go with the third limitation, that is it cannot be used to derive equations involving addition and subtraction. Addition and subtraction. Okay. If the equations have addition and subtraction, you cannot derive by using dimensional analysis. For example, there is an equation of motion, that is v is equal to u plus at. This cannot be derived by using dimensional analysis because it has what now here? Addition, right? If it has addition or if it has subtraction, it cannot be derived. If it has multiplication division, yes, we can derive it. But if the equation has addition and subtraction, we cannot use dimensional analysis to derive such kind of relation. So these are some of the limitations of dimensional analysis. All the physical quantities have units and dimensions, but there are some exceptions. Let us check it out. Let me take them under note points. Okay, first one. Some physical quantities have neither units nor what we say here dimensions. There are some physical quantities, they do not have units as well as dimensions. So what are they? Let me take some examples. Right. So examples of such quantities which do not have unit as well as dimension. Examples are strain. There is a physical quantity called strain, and there is a physical quantity called refractive index. Right. You will be learning about this in the further classes. Okay. What is strain? Do you remember the formula for strain is change in length divided by original length. Change in length divided by original length. Okay, what is the SI unit? Let us check it out. SI unit of change in length, meter. SI unit of length is what? Meter divided by what is original length? It is also meter. So they will get cancelled. That is the reason strain do not have any unit. Right? Why it is not having any unit? Because they get cancel each other. If numerator and denominator have the same physical quantities, such physical quantities do not have any units here, right? So these do not have any units, right? Strain is not having any unit. Let us check it out. Is it having any dimension? So change in length, dimension is length itself, right? Divided by original length. What do you get now? This will get cancelled. That will L raised to 0. It is not having dimension now, right? So strain is not having unit as well as dimension, right? So this is one of the example. We know what is the formula for refractive index. In optics, you will be studying about refractive index. What is the formula? That is speed of light in vacuum divided by speed of light in medium. Speed of light in what we say here, medium. What is the formula for refractive index? The formula for refractive index is speed of light in vacuum divided by speed of light in medium. So what is the SI unit of speed? Meter per second. What is the SI unit of speed? Meter per second. They cancel each other. That is why refractive index do not have any unit here. Let us check it about dimensions. What is the dimension of speed? L t raised to minus 1. Speed is nothing but velocity, right? Okay, what is the dimension? L t raised to minus 1. Again, they get cancel each other. That is the reason why refractive index do not have any unit as well as dimension. So these are the examples of such physical quantities which do not have units as well as dimensions, right? Okay, so this is the first exception. Let me go with the second exception. Some physical quantities have units. There are some physical quantities in nature which have units but no dimensions. They are not having dimensions, right? Let me take such examples. Let me take the example of physical quantity which have units but no dimensions now here, right? Okay. Example is plane angle or solid angle, right? Another example is solid angle, right? We know what is the SI unit of plane angle? Radian. You have studied, right? Fundamental SI units, and these were the supplementary SI units, right? What is the SI unit of solid angle? Steradian, right? Okay. These quantities have units but no dimensions. Let us check it out. What is the formula for plane angle? Plane angle, the formula, you know, the plane angle is the angle on the plane here, right? If it is a circle, that is, this is radius and this is arc now here. We know what is the formula for a plane angle? That is arc divided by what we say here? Radius. Length of arc divided by radius now here, right? Okay. We can take length of arc divided by a radius. Yes, divided by r. That is the formula for plane angle. Okay. Now, let us check it out. Length of arc divided by radius. Okay. What is the dimension for length of arc? L. What is the dimension for radius? That is also L. Radius is nothing but length, right? So what do you get? Again, they cancel each other. Okay. Means plane angle do not have dimension. Right, but it has SI unit. What is the SI unit of plane angle? That is radian, right? So do remember this. Plane angle is an example for a physical quantities which have unit but no dimensions, right? Plane angle. And we also have one more, that is solid angle, right? What is solid angle? The same angle. Let me take now here. It is like this now, right? This angle, right? So if you take a cone, right, the angle which is formed at the bottom, that is nothing but what we say here, solid angle, right? So we will be learning about this much in the later classes. What is this? This is area. And what is this now here? It is a radius. The formula for solid angle is area divided by a radius square, right? Area divided by radius square. Can I calculate its dimension? Okay, let me go. Dimension of area is length into breadth. L square. What is the dimension for radius square? That is also what? L square. Again, they get cancelled, right? So we will be getting with L raised to 0 now here, right? So we will be getting L, means it is not having any dimension, but it has SI units, right? It has unit. What is the unit of solid angle? Steradian, right? So these are some of the physical quantities which have units but no dimension. So these are some exceptions. Let us go with the third one. Constants are of two types. There are two types of constants. One is dimensional constants and another one is non-dimensional constants. non-dimensional constants. Okay, constants are of two types, dimensional constants and non-dimensional constants. So what are dimensional constants? Dimensional constants, let us check it out. These are constants having dimensions. There are some constants which have dimensions, so that kind of constants are called as dimensional constants. Okay, now let me take example for dimensional constants. The example for dimensional constant is gravitational constant. Gravitational constant, right? That is a constant which has dimensions. Even Planck's constant. Planck's constant. So these are the constants having dimensions. Okay, now let me give an example now here. Dimensional constant, that is gravitational constant. Let us find what is the dimension for gravitational constant. Okay, first of all, just think it out. Where do you get this dimensional constant? From universal law of gravitation? What does universal law of gravitation says? That is F is equal to G m1 m2 divided by d square. You know, from a law of gravitation, from universal law of gravitation given by Newton, we got gravitational constant. What is the gravitational constant? G. So what is the formula? F is equal to G m1 m2 divided by d square, right? This is the formula what we get from Newton's law of gravitation, right? Universal law of gravitation. It says that the force between any two bodies is directly proportional to the product of the masses and inversely proportional to the square of the distance between them, right? So we got this formula now here, right? From here we will be finding what is the dimension for gravitational constant. Okay, first let me write G equal to, what do you get? G equal to F d square divided by m1 m2 will come to the denominator. What do you get now here? m1 m2. F d square divided by m1 m2. Now we can easily find dimensions. Okay, write the dimension for force. What is the dimension for force? Mass into acceleration. What do you get? Mass, acceleration, Lt raised to minus 2. What is the dimension for distance? L square, right? Distance is nothing but length, right? Divided by m1 m2, m and m. Shall I write like this, right? So m1 m2, so we get m and m. So what do you get now here from this? Let me substitute m. Here there is 1, m square. If it go to the numerator, m raised to minus 2 now here, right? So L, we have 1 plus 2 because we have L here. T, how much do you get now here? Minus 2, right? Shall I write like this, right? So this can be written as, what do you get now here? M raised to minus 1, L raised to 3, T raised to minus 2. So this is dimensional formula for G. What is G? G is gravitational constant, right? So G is gravitational constant, and this is the way we calculated the dimensional formula for gravitational constant, right? Even though this gravitational constant is a constant, it has dimensions. That is why I written constants having dimensions are called as dimensional constant, and the example is this gravitational constant, and we got the dimensions for gravitational constant. Now let us say non-dimensional constants. Non-dimensional constants. Okay, we studied about dimensional constants. Now we will be going with non-dimensional constants. What are these? These are constants having no dimensions, right? There are some constants which do not have dimensions at all. So those kind of constants are called as non-dimensional constants. And let us take example. You will come to know here, right? If I am taking the example, pi is a constant. You know what is its value? 22/7, right? So pi, any number if you take, these all are not having any dimensions, right? Any number, all the numbers do not have any dimensions, so they come under non-dimensional constant. Pi is also a non-dimensional constant. You know what is the formula for pi? I think you heard about the pi. Where do you get? What is the value of pi? That is 22 divided by 7. What is the meaning of this? Right? We know the formula for pi is circumference divided by diameter, right? You heard about it. What is pi? It is the ratio of circumference divided by diameter. Any circle if you take, right? If circumference is 22, then diameter is 7. That is the meaning of this. If circumference is 22 centimeter, diameter will be 7 centimeter, right? So the formula for pi is, it is the ratio of circumference to the diameter, right? Okay, calculate its dimension. Circumference, it is nothing but length, right? Circumference is length. Diameter, yes, it is also length. Again, they get cancelled. L raised to 0, which do not have dimension, right? So pi is a constant which have value but it do not have any dimension, right? So as it is not having any dimension, it come under non-dimensional constants, and I already told you all the numbers are do not have any dimensions, so they come under what we say here, non-dimensional constants. So constants are of two types, dimensional and non-dimensional. So this was all about dimensional analysis, and this is the end of the chapter, units and measurements. Thank you.